All right, let's dive right in. Today we're talking about something called computer vision. It's the amazing science that's teaching machines to do something that's so fundamentally human, to not just look at the world, but to actually see it.
I mean, have you ever stopped to wonder about that? How does a self-driving car know the difference between a stop sign and a kid's red balloon? How does it stay perfectly in its lane even on a curvy road? Honestly, it feels a little bit like magic, but it's one of the most incredible examples of computer vision in action.
But here's the thing, it's not magic at all. It's a whole field of science that's dedicated to something pretty audacious, replicating our own ability to see one of the most complex things in biology and basically installing it into a machine.
So where does this journey even begin? Let's start with what it means to give a computer the gift of sight.
Okay, so at its core, computer vision is a part of AI that's trying to solve a massive puzzle. You know, a camera can snap a picture, no problem. But how do you get a machine to understand what's in that picture? That's the whole goal here, to process all that visual information and pull out actual meaning, pretty much just like our own brains do every second of the day.
Now, this is where it gets really fascinating. Because to teach a computer how to see, we first have to understand how a computer sees an image in the first place. And trust me, it's not what you think.
You know, when you look at a photo of, say, a sunset, you see the brilliant colors, the clouds, the horizon, you see a scene, a feeling. But a computer doesn't see any of that. So what does it see? Yeah, it sees numbers. To a machine, every single image you've ever seen, a selfie, a masterpiece painting, a medical scan, is just a giant grid of numbers. That's it. That's the fundamental secret to this entire field.
And each one of those numbers corresponds to a single tiny dot of light in the image. We call that dot a pixel. Now, in a simple black and white picture, that number just tells the computer how bright that one specific dot is.
Let's make this real. For a grayscale or black and white image, it's a simple scale. A value of 0 means that pixel is pure black. A value of 255 means it's pure white. And all the numbers in between? Well, those are all the different shades of gray. So the computer isn't really seeing a shape. It's learning to recognize patterns in all these numbers.
Okay, so black and white makes sense. It's one grid, one set of numbers. But what about color? I mean, how does a computer handle the millions and millions of colors our eyes can see? Turns out, the solution is actually really clever and surprisingly simple.
Instead of just one grid of numbers for brightness, a color image uses 3 of them. It's basically 3 grids stacked right on top of each other. There's one grid for how much red is in the picture, one for green, and one for blue. You've probably heard this called RGB.
And you can see it right here. You can take any color photo and literally pull it apart into these 3 separate layers, or channels. Each one is basically a black and white map that just shows the intensity of that one color. Then you just stack them back together and poof, you get your original full-color image.
So what this means is that every single pixel now has 3 numbers attached to it. One for red, one for green, and one for blue. And each of those can range from 0 to 255. By just mixing those 3 values, a computer can create over 16 million different colors. It's pretty wild.
Okay, so we've established that a computer sees grids of numbers. But how in the world does it get from just a bunch of numbers to actual meaning, to understanding that's a dog or that's a car? Well, that's the next step. We have to teach it to see.
And this isn't just some fun thought experiment. This stuff has real life-saving applications. For example, diagnosing pneumonia from a chest X-ray can be tough, even for highly trained doctors. This makes it a perfect and really important job for computer vision.
The whole process follows a pretty standard recipe. First, you need ingredients, and in this case, that's a ton of data. We're talking thousands of X-rays that doctors have already labeled as either normal or pneumonia. Then you have to prep the data, clean up the images. After that, you pick your tool, an AI model, and finally, you start the training, feeding all that data to the model so it can start learning.
So what does learning actually look like for the machine? Well, it uses a special kind of AI model that's built for images. You can think of it like a tiny detective with a magnifying glass. This little detective scans across the image's number grid over and over. But it's not looking at the whole lung at once. No, it's looking for tiny clues, little patterns in the numbers that might represent an edge, a certain texture, or maybe those telltale cloudy spots that indicate pneumonia. After it sees thousands of examples, it gets incredibly good at knowing exactly which patterns to flag.
So that's the big idea. And once you give a machine this ability to find meaningful patterns in pixels, the applications just explode. This isn't science fiction. This technology is already all around us, shaping our world in ways you might not even realize.
In healthcare, it's way beyond just X-rays. It's analyzing MRIs and CT scans, spotting tumors earlier than a human eye might. And in our cars, it's the absolute core tech that's able to say, hey, that's a pedestrian, not a mailbox, or that's a stop sign coming up. It's what keeps the car safely on the road.
It's also completely changing how we shop. You know those apps where you can virtually try on glasses or makeup? That's computer vision mapping things to your face. And those checkout-free grocery stores where you just grab stuff and leave? That's a whole bunch of cameras watching and understanding what you took. In factories, it's like a superhero inspector spotting microscopic defects on an assembly line faster and more accurately than any person ever could.
The scale just keeps getting bigger. Farmers are using drones equipped with this tech to fly over their fields and spot sick plants from the air. And then you go to the other extreme, outer space. It's this same fundamental technology that helps a rover navigate on Mars or allows a spaceship to automatically find a safe place to land, avoiding rocks and craters all on its own.
So, we've given machines this incredible gift of sight, the ability to turn meaningless grids of numbers into real, actionable understanding. It's already doing everything from diagnosing disease to exploring other planets. The technology is reshaping our world as we speak. So the only real question left is, what will we teach them to see tomorrow?